n minus 1. Then for I equal to 0, I less than n minus pass minus 1 and then I plus plus. In every path, what you are doing, you are just comparing a of 0 with a of 1, a of 1 with a of 2, a of 2 with a of 3. And what you are doing, in every path, number of elements to be sorted is decremented by 1. Yes or no? Before I start pass 1, I have a number of elements. After completing pass 1, before I start pass number 2, I have n minus 1 number of elements. Similarly, at the beginning of pass 3, I have n minus 2 number of elements. That's why I am subtracting 1. And this second inner for loop is just for the comparison. In every pass we are comparing. So for that comparison, I have used this for loop. Okay. Now what I need to do inside this inner for loop? Let me write it here. Okay, so what we are doing when I compare, what we are doing, we are comparing or we are checking that a of 0 is greater than a of 1 or not. A of 1 is greater than a of 2 or not. So I use a if statement here. If a of I is greater than a of I plus 1. Okay, then what I need to do? I need to swap. When a of I is greater than a of I plus 1, what you need to do? You have to swap them. How do I swap? Like temp equal to a of I, then a of I equal to a of I plus 1, and a of I plus 1 equal to temp. The end of this if statement, the end of inner for, end of outer for, end of the function. Okay, this is the C function for your bubbles. The outer for loop I have used because I need maximum n minus 1 number of passes. Inner for loop I have used because I need to compare a of 0 with a of 1, a of 1 with a of 2, a of 2 with a of 3. Inside this inner loop, if a of I is greater than a of 1, a of I plus 1, then I need a swapping. So that swapping I will do with the help of these three lines. If here now, your job is you have to write the entire program. That God function part already I have written. Only calling function, main function part you have to write.
Sir, can we print this? There is something step by step something. Can we see to this? Can we to this can we use print function?
Means you want to print whatever the result after the end of that particular pass. That you want to print, or what is the largest element which is placed at the last location, that you want to print. You have to use simply printf function. Printf function. But where you will write that printf function, it is your job. You find out that. I will not tell you. Only by writing printf function, suppose my objective is pass 1 is over, and at that time, after the end of pass 1, what is the condition of my array? Okay, means some swapping will be there, definitely there after the end of this pass 1. So initially my array is this one. Now after the end of pass 1, what is the condition of my array? If you want to see that, if you want to display that, you have to use printf function. Okay, or you simply call your display function where you will display the entire array. So where to call it, how I will write that printf function, this is your job, I will not tell you. Somewhere inside this you have to call your display function and you have to pass your array. But where to pass you have to find out. Easily you can find out. This is not a very big thing. Where will write your array? Suppose I have to call my display function. After every pass, whatever the condition of my array, I want to display that. Where I will keep it? This one. Here. Either before this inner for loop, not before this inner for loop, just after this inner for loop, you call your display function and you pass the array along with the number of elements n, so that after the end of each and every pass, what is the condition of your array, that will be displayed by the display function. That means after this second end curly braces, you have to call your display function. Now come to the next second technique, which is insertion sort. I don't think that it is required to explain this logic with the help of an example. Is it required? Is it required? Should I explain the logic with the help of an example? No. Come to the second sorting technique, which is insertion sort. Insertion sort. You note down two parts first, then I tell you the technique. Bubble sort, you write down the complexity. Every sorting and sorting technique, you write the complexity and remember the complexity also. Insertion sort, write down. Insertion sort is an efficient technique. Insertion sort is an efficient technique to sort small number of elements. Insertion sort is an efficient sorting technique to sort a small number of elements. Next point. The technique of insertion sort is similar to the arrangement of cards by a card pair. Similar to the arrangement of cards by a card pair. Next point. In insertion sort, put a comma there. In each state, we are inserting an element. In its appropriate position in a previously sorted sub-array. Now look at the code. So this technique, the technique of your insertion sort, it is exactly similar as the arrangement of cards by a card player. Normally what a card player does, card player picks up a card and insert the card in its appropriate position. Yes or no? Similar technique we have for insertion sort. In insertion sort, when you have n number of elements, then you need n number of states or n number of passes also to sort the entire array. So in step 1 or in pass 1, what I do? I need not to do anything in step 1 or pass 1. just I'll assume that A of 0 is trivially certain. So in step 1 or in pass 1, I need not to do anything. Just I assume that whatever element is there at the 0th location of my array, that element is already certain. You forget about the rest of the elements. You only consider the 0th element and you assume that this 0th element is already certain. Okay, this thing you have to do. Then you start pass 2. See, in insertion sort, if you refer different books, in some book you get that it requires exactly a number of steps. In some other books you can find out that insertion sort requires n minus 1 number of steps. So why there is a variation? Because of this pass 1. Since I am not doing anything in pass 1, just I am assuming something. That's why in many other books they have ignored pass 1. So if I ignore pass 1, I need exactly n minus 1 number of steps. If I include pass 1, I need n number of steps. Are you getting it? When I write the C function, I will exclude this step 1. Okay. So pass 1, you need not to do anything. You have to just assume that whatever element is there at the 0th location, that element is certain. Now pass 2. So in pass 2, what I do? Now I take the first element of my array. Like the card where picks up a card, insert it in its appropriate position. Similarly, what you need to do, you take your first element of your array, you insert it in its appropriate position so that after insertion, A of 0, A of 1, both will be certain. Are you getting it? And in insertion sort, normally what we are doing, we are taking an element, we are inserting it in its appropriate position in a previously certain sub-array. That means when I insert A of 1, before I insert A of 1, definitely A of 0 needs to be certain. When I insert A of 2, before I insert A of 2, A of 0, A of 1, these two elements needs to be certain. Then only I can insert A of 2. When I insert A of n minus 1, before I insert A of n minus 1, A of 0 to A of n minus 2, all the elements needs to be certain. Then only I can insert A of n minus 1 in its appropriate position. That's why I have detected the last one. You will insert a new element in its appropriate position in a previously certain sub-array. The entire array, whatever array is given, you take an element, you insert it in its appropriate position. But before you insert, definitely the sub-array, before to that element, whatever elements are there, they need to be certain. Then only I can insert the next element. Okay, so first element in step 1, just I have assumed that my 0th element is certain. In pass 2, what I need to do, I take the first element, but before I insert my first element, A of 0 needs to be certain. That's why step 1 is required. Are you getting me? Before I insert the first element of my array, the 0th element needs to be certain. Then only I can insert my first element. So that is the requirement of pass 1. Otherwise, you can skip it also because we are not doing anything. So what I take, I take 33. My first element is 33. I will insert 33 in its appropriate position so that after inserting 33, A of 0, A of 1 will be certain. So what I do? 33, 44, 77. You forget about the rest of the elements. Only these two. In step 1, only A of 0 is certain. In step 2, A of 0, A of 1, both will be certain. Is it clear? Pass 2. Pass 3. Similar process. What I need to do? I take the second element of my array. But before I insert second element, A of 0, A of 1 must be certain. Then only I can insert A of 2, the second element. So A of 0, A of 1, these two are already certain after the end of your pass 1. So now I take 77. I insert it in its appropriate position so that after inserting 77, A of 0, A of 1, A of 2, all the three elements will be certain. So in this case, I need not to do anything. The third element is already certain. Means the second element of my array is already certain. Here, then come to pass 4. Again same process. What I need to do in pass 4? Which element I take? A of 3, the third element. Before I insert A of 3, A of 0, A of 1, A of 2 must be certain. Then only I can insert A of 3. So already at the end of stage 3, A of 0, A of 1, A of 2 is already certain. So I take the third element of my array, A of 3, which is 55. I'll insert it in its appropriate position so that after inserting 55, A of 0, A of 1, A of 2, A of 3 will be certain. So what will be its appropriate position? 33, 44, 33, then 44, then 55 and then 77. These four elements, A of 0 to A of 3 must be certain. Then I'll get 8, then I'll have 88 and 66. Then pass 5. Again similar process. Before I insert A of 4, the fourth element, A of 0, A of 1, A of 2, A of 3 must be certain. Then only I can insert A of 4. So you take 88, insert it in its appropriate position so that A of 0, A of 1, A of 2, A of 3 and A of 4, all the 5 elements will be certain. Again it is there in the right position, 55, 77, 88. So A of 0 to A of 4, all are certain. Then pass 6. Similar process again. Finally get 33, 44, 55, 66, 77 and 88. Now the entire array is certain. So here I need exactly a number of states. If I will include pass 1, if I will exclude pass 1, I need n minus 1 number of states. So whatever books are following, if it is written n or n minus 1, both are correct. But for n minus 1 case, you have to assume that step 1 is skipped. It is ignored. Okay, so this is the technique of your insertion sort. And in the examination, university exam, if pass by pass representation is asked, let's say this is the question, what is the result after pass number 4? Okay, so you have to step by step represent what is happening in step 1, what is happening in step 2, what is happening in step 3, and also theoretically 1 or 2 line you will write there, that will be better. Suppose pass 1, just I'll write that A of 0 is trivially certain. Then pass 2, theoretically, or you first represent that, then I'll write, I'll take the first element of my array and then I'll insert it in its appropriate position so that after insertion A of 0, A of 1 will be certain. If you write these 2-3 lines theoretically, then you will represent it, again it is better also. Okay, so for every step, what is going on in that particular step? You will write 1 or 2 lines and then you have to represent that. Here, this is called a step-by-step representation. There also, you have to prepare for this type of question also. Okay. Now let us come to the C function part. The function name is insertion sort. Insertion sort. Again, I need to pass my entire array. I need to pass how many elements are there in the array. So for my calling function, I need to pass these two parameters. I need different variables like integer, need I, need j, need p element also. Okay. Let's see if you require any other variable, I will also declare that. for j equal to 1, j less than n, j plus plus. How many times this loop will continue? N minus 1 time. Okay, that means I have skipped pass 1. Pass 1 you are not doing anything, so just assuming that f0 is certain. So I have ignored that pass, so my loop will continue for n minus 1 over time. What I write? The key element is, let's say, a of 0, a of j, and I value is j minus 1. Key is a of j and I is j minus 1. What I am doing? While, see, what we are doing, suppose let's say 33, 44 is already certain. Now you have, you forget about this example, let's take another example. 33, 44 and let's say 22 is here. Okay, I will insert 22, this element. But before I insert this element, a of 0, a of 1, they must be setted, then only I can insert a of 2. Okay, so what I need to do here, first I will compare this element with this element. Okay, when a of 2 is greater than a of 1, before I insert a of 0, a of 1 is already setted, remember. Okay, now I have a new element a of 2. So first I will compare a of 2 with a of 1. So when a of 2 is greater than a of 1, definitely a of 2 is also greater than a of 0. Because a of 0, a of 1 are already setted. So when a of 2 is greater than a of 1, then definitely a of 2 is also greater than a of 0. That means a of 2 is already setted, it is there in the right position. Okay. Suppose a of 2 is less than a of 1. What I need to do? First I'll swap this two. This will be 22, this will be 44. Then again I need to compare whether a of 1, means after swapping, whether a of 1 is greater than a of 0 or not. Okay, let's say this element is something else, 35. So a of 1 will be greater than a of 0. That means a of 1 is already placed in the right position. Yes or no? If it is not, that means if a of 1 is less than a of 0, again I need a swapping here. Finally I have 22, 33, 44. So my point is here, up to what I need to compare, up to what value? My condition, if I write here, while I is greater than minus 1, you understand why I have written I is minus 1? Because after 0 I do not have any other index here. So when I is greater than minus 1 and a of I is greater than my key value, whatever element I take, so that is my key element. So if my key element is less than its previous element, at that time I need swapping, and up to what I need to continue, up to this minus 1 position. So my condition is while I is greater than minus 1 and a of I is greater than key, both are, this I have used logical and operator there. So one condition, this is another condition. Okay, fine. What I need to do? I will do a of I plus 1 equal to a of I, and then I is decremented, I equal to I minus 1. Okay, and then after this while loop, a of I plus 1 equals to your key element. After this while loop, and then finally end of my for loop, end of my function. Let us take this example. Okay, let us go for a diagram with that help of example 34, 33, 44, 22 is there. This is your array. You want to sort them in the increasing order in insertion sort. Okay, using insertion sort you will sort it. So let's see. This one, a of I plus 1, because I have decremented I value, so I need to increment it. A of I plus 1 will be key. So let us execute this C function with the help of this example. It's a small array. Okay, only 3 elements are there. So n value is 3 here. So let us look at the first for loop, the outer for loop. For j equal to 1. Now j value is 1. J less than n, j is 1, n is 3. So 1 less than 3, condition is true. True means now control enters into the body of my outer for loop. So now key is a of j, a of 1. A of 1 means 44. Key value is 44. I is j minus 1. J minus 1 is 0. Okay. I is j minus 1 is 0. Come to this while. While I greater than minus 1, 0 greater than minus 1, true. And a of I greater than key, a of 0 is 33, greater than key, 44, false. 33 greater than 44, false. That means one part is true, one part is false. The entire condition is false. So control will come outside of this while loop. Yes or no? Yes or no? Yes. So after this while loop I have a of I plus 1 equal to key. I value is 0. So a of 1 equal to key. Key is 44. Already it is there in the first location. Are you getting me? So next iteration in my for loop, my j is incremented. J value is 2. J is 2. 2 less than n. 2 less than 3. Satisfied? So key is a of j. A of 2. A of 2 means 22. Now key is 22. I equal to j minus 1. I is 2 minus 1 is 1. Okay. So j value is 2 now. I value is 1. Look at this while. While I greater than minus 1. I value is 1. 1 greater than minus 1. True. A of I, A of 1 is 44. Greater than key is 22. 44 greater than 22. True. So both conditions are true. My resultant condition is true. So body will be executed. A of I plus 1 equal to A of I. Okay. What is A of I? A of I means 1. So A of 1. A of 1 will be assigned to A of 2. So A of 1 is 44. So this element A of 2 will be replaced by whatever element I have in A of 1. Are you getting me? Is it clear or in doubt? A of I plus 1 equal to A of I. Whatever value of A of I value is 1, A of 1, which is 44. Now that I will store in A of I plus 1, A of 2, that means 22 is lost, that is overwritten by 44. Okay, now in A of 2 I have 44. Then I is decremented, I equal to I minus 1. So I value is 0. Here, then again while loop, I greater than minus 1, 0 greater than minus 1, true. A of 0 is greater than key, A of 0 is 33, greater than key. What is the key value here? Key is, it is written 22. So 33 is greater than 22. Yes, both the conditions are true. So A of I plus 1 equal to A of I. A of I means 0. A of 0 will be assigned to A of 1. So now this element will be overwritten by 33. Clear? Then I is decremented. Now I value is minus 1. I greater than minus 1. Now this condition is false. The next iteration of your while loop, this condition is false. So control come outside of this while. A of I plus 1 equal to key. I value is minus 1. So minus 1 plus 1. A of 0 will be key element. Key is 22. So A of 0, this element will be 22. Clear? Then in my outer for loop, when j is incremented, my loop condition is false. Are you getting it? Since I have decremented it, so definitely it will be I plus 1. Is it clear now? So first we write down this logic, and complexity of this insertion sort Tn is also theta of n square. Its complexity is also theta of n square. Quickly write down the logic. And have one more sorting technique, one more searching technique. Today you may not get sufficient time to complete the assignment. Okay, but since I have discussed almost key things here for all the four programs, so your job is you have to complete your assignment in the internet. Okay, all the called function for all the four programs I discussed. Only your job is to write the main function. Okay, so that's why whatever time you get, try to complete that. Complete your assignment. If it is not completed in the internet class, you have to complete it. No other solution. Next class we'll start a new assignment. Ready to go? While loop ends here, that is the end of your for loop, end of the function. Okay, fine. Over. Over. Can I erase this? Okay, your job is today itself. You take different examples and try to write on your C function on that particular example so that you will be more clear. You will solve at least one or two examples with this logic, then you will be more clear on the technique of whatever setting we are discussing. How is what is the technique, how the C function works, everything will be clear. It will solve one or two examples. You take any array, randomly put the elements, try to write on your C code, the C function. Okay. Now coming to one more setting technique which is called as selection sum. Selection sum. Suppose this is the array. 0, 1, 2, 3, 4, these are the locations. You tell me the element, randomly you tell me the element. Huh? 1, 2, 3, 4, 5 is already certain, then why do I take that example? Randomly you tell me, in random order. 11, next. Huh? 11, then next. 18. Again increasing order. Then 33. Take only 3. Then 25. Okay. 39. 56. Let's take 2. Fine. Randomly you have to select any 5 elements. So this is the array containing n number of elements is given to you. And now the technique is selection sum. Carefully listen what you need to do in pass 1. Now before I start pass 1, how many elements are there to be certain? Before I start pass 1, there are n number of elements to be certain. Yes or no? My array contains n number of elements. So before I start pass 1, I have n number of elements to be certain. So what is the technique of selection sum? The technique says that you first find out the largest element among those n number of elements of your array. Okay, you find out which one is largest. Okay, among those n number of elements. Since I have n number of elements at the beginning of pass 1, so you find out the largest element among the n number of elements. Which one is the largest element? 25. Okay, so let I is the location of the largest element, among the n number of elements. Repeating, I is the location of my largest element. I have a number of elements. Whichever element is my largest element, in whichever location it is there in my array. So that is the value of I. I represents the location of the largest element among the n number of elements. So once I will find out I, what I need to do, I have to swap a of I with a of n minus 1. Once I will swap, it's the end of my pass. And getting me in step 1, what we are doing, before I start pass 1, I have n number of elements. So first I will find out which one is the largest element. So whatever largest element I will get, let's say I represents the location of my largest element among those n number of elements. So after getting I value, I need to swap a of I with a of n minus 1. Okay, so then I need to start pass 2. So my question is, what will get after the end of pass 1? What will get after the end of pass 1? After the end of pass 1, a of n minus 1, this element must be certain. It must be certain. Yes or no? What I have done here? Find out the largest element. Largest element is 25. So I value is 3. Okay. What is the value of n here? N is 5. N equal to 5. So I need to swap a of I means a of 3 with a of n minus 1. A of 5 minus 1 is 4. So a of 3, a of 4. For this particular example, they will be swapped. So here I will have 2, here I will have 25. So after the end of pass 1, definitely a of n minus 1. Whatever element will be there at the n minus 1 position, that element is already certain. You clear? This thing I need to do. And this is the result after pass 1. Then start pass 2. Now at the beginning of pass 2, now how many elements are there to be certain? How many elements? Out of 1 element, 1 is already certain. A of n minus 1 is already certain. So now I have n minus 2 number of elements. I have n minus 2 number of elements to be certain before I start pass 2. Yes or no? No, sorry. I have n minus 1 number of elements. Out of n, 1 element is only certain. So I have now I have now n minus 1 number of elements to be certain. So again, similar process. What you need to do? You find out the largest element among those n minus 1 number of elements. Okay, in pass 1, what we are doing? We are finding out the largest element among n number of elements. Since after the end of pass 1 element is already certain, a of n minus 1 is already certain. So now I have only n minus 1 number of elements to be certain. So again I need to continue the same process. I will find out the largest element among those n minus 1 number of elements. Let I be the location of my largest element among those n minus 1 number of elements. So what I do? Again I will compare, means I will swap a of I with a of n minus 2.